We should be very cautious with using tasks in Qwik. Especially heavy use of useVisibleTask can eliminate the benefits that we gain from using Qwik in the first place. In this video we will cover some issues that are related to tasks in Qwik, and we will see what we can do instead. But before we start, let's make sure that we are on the same page. As it's written in the docs, tasks are meant for running asynchronous operations as part of component initialization or change of component state. They are basically the counterpart to useEffect in React. With that in mind, let's quickly recall what makes Qwik so performant. The goal of Qwik is to enable us to write instant-on applications which delay the execution of JavaScript as much as possible. This leads to a short time to interactive, and this is really great for the SEO score. For this, Qwik comes with an optimizer which allows us to write splittable code. Possible split points are marked with a trailing $sign in function names and function properties. During SSR, the optimizer will take those marked expressions and turn them into importable modules. Those are then fetched on demand from the client. Because of this, many functions coming from Qwik end with a trailing $sign, and this is also true for useTask and useVisibleTask. This is great, but there are still some things we developers have to consider. We can still write code that loads those splitted modules before they are actually required. For this lazy loading of modules, Qwik comes with a quick loader script which is embedded into the HTML. To maximize the benefits we get from Qwik, we need to know when the Qwik loader loads the modules. Let's now have a closer look at the useTask factory. A task created with useTask will run the first time on the server before rendering. When declaring the task, we can use the track function to track state changes within our component. If we don't do this, this task will never be re-executed in the browser. When the server-side rendering is done, the HTML which is created here will be fetched by the browser. If then in the browser any action leads to a change of this state, the task will be re-executed. For this, the Qwik loader has to load the task implementation from the server. Splitting out the task's implementation can lead to performance gains in 3 scenarios. First, if we don't track any state in our task, then the task implementation doesn't have to be shipped to the browser. So splitting it out is a good decision. Second, if we track state in our task, it may be that the browsing behavior does not lead to an action that changes this state. So in this case, it was also a good decision to not ship the code to the browser. And third, if we track state in our task and the state doesn't change immediately after loading the application, we still hit our goal to minimize the time to interactive of our application. So in general, useTask is a good fit for building instant-on pages. This does not mean that useTask is always the best choice for triggering side effects. It comes with some limitations. One example is that it blocks rendering until the asynchronous callback is done. But more on this later. Now that we covered useTask, let's take a closer look at useVisibleTask. useVisibleTask runs only in the browser, and it is eagerly executed when the component becomes visible. Becoming visible in this context means that the first element rendered by this component enters the viewport. And in contrast to useTask, tasks registered with useVisibleTask will not block rendering. So with code splitting of useVisibleTask, we have performance gains in 2 scenarios. First, if the component never becomes visible, we have the maximum performance gain because the code will never be loaded. Second, if the component is not visible initially, but gets visible later on, we still improve our time to interactive by splitting out the code. All in all, there are some performance and code quality concerns related to tasks, which we want to avoid. Luckily, Qwik provides some other ways to trigger side effects. We should be aware of those because they can improve our performance or code quality. Let's now investigate some common use cases where we may find better solutions than tasks. One common topic is event handling. Visible tasks can be used for events that are related to the current component. Those may be local events which are emitted on the component or its children, but it can also be global events like visibility change or scroll, which have to be captured on the document or window object. In our showcase we will implement a scroll spy which listens to the global event scroll on the window object. For this we use a scroll indicator component that will render out the current scroll value in % within a progress bar. An implementation of the scroll spy with useVisibleTask can look like this. We have an onScroll handler that handles the scroll events of the window object. We calculate the scroll value by dividing the scroll offset by the scroll range. When our component gets unmounted, we have to remove the global event listener again. As you can see by this disabled ESLint rule, it's not recommended to use useVisibleTask by default. I'm currently running the optimized application in preview mode. So here we see the resulting bundles that are generated by the Qwik optimizer. As we can see in the first script that is loaded here, the task implementation is already fetched. And when we scroll down, another script is loaded, and that's the implementation of the scroll indicator because it has to be re-rendered. One issue that I want to point out here is that we have to clean up our event listener on the window object. If we forget this, we have a potential memory leak. So this is how we could implement a scroll spy with the useVisibleTask hook. Okay, let's now have a look at another solution with property functions. In Qwik we can register global event handlers on document or window with the document colon or window colon prefix. So if we want to lazily capture the window scroll event, we can use window colon on scroll $. We see that with this solution, initially no JavaScript is eagerly fetched by the Qwik loader. If we now scroll down, the implementation of the scroll handler is lazily fetched, and the component must be re-rendered so it's fetched as well. Another benefit of this solution is that we don't have to clean up this event listener. This is automatically managed by Qwik when the component is unmounted. Another way to implement the scroll spy is by using the useOnWindow function. We can use the useOnWindow or useOnDocument function from Qwik to listen to events programmatically. This allows us to build our own hooks or dynamically determine our event name. The useOnWindow function is not suffixed with the $sign because the Qwik optimizer only looks at the first argument that is passed to the function, which in our case is the event name and not the handler. We have to manually wrap our function with the $function from Qwik. If we look at the result, we see that it behaves similar to the function properties solution. The event listener is fetched here. So as we saw, the useVisibleTask is not a good fit for asynchronous event handling. The next use case I want to cover is asynchronous loading of data. what we are actually implementing here is an autocompletion feature. Occasionally we want to fetch data from an API within the browser. In this case we can use useVisibleTask again. A useVisibleTask solution can look like this. We have three signals here. One is the query, then we have a loading status and the results. Then we have our task registered here and we track the query to re-execute when this query changes. So if the query is empty, we want to have no results, so we set the results to an empty array and return. If the query is not empty, we set the loading status to true, then we fetch the data and assign it to the results and reset the loading status to false. Remember that useVisibleTask is not blocking rendering, so we can safely do this and await the search here. In between will be a render of the component. Let's quickly look at the template. We have an input field with an onInput handler. This will simply update our query signal. If we have loading set to true, we simply render out a loading string. And if loading is not true, it means that we can render our results. We do this here. Let's see this in action. As we see, the implementation is eagerly fetched with useVisibleTask because this input field is visible. If we scroll down and reload the page, we see that no JavaScript is loaded yet, and when we scroll up, the JavaScript is lazily fetched. When we enter a value here, we see the loading indicator and then the results rendered out. So far so good, but when do we actually need the implementation of the autocompletion search? Not when the input field becomes visible, but when we enter text into the text field, right? So let's have a look at an alternative with tasks. As we see, this looks very similar to the VisibleTask implementation. Actually, this code is the same. But now comes an important difference. We want to show this loading text to the user when the search results are loading. So with tasks, we must not wait for the search results here, because the task will block rendering until this asynchronous function is complete. So here we use promise chaining to assign the results to the signal and we reset the loading state. This solution is not very clean because it only works with an empty query initially. If it would not be empty, we would end up with a dangling promise over here. What's good about this solution is that the lazy loading of the JavaScript actually works. So if we enter a value here, the JavaScript is fetched. But there is also another solution that's specifically made for this use case, and it's provided by Qwik. It's called useResource. As we can see in the documentation, useResource is similar to useTask, but it allows returning a value instead of doing a side effect and setting a signal, for example, and it does not block rendering. So if we want to implement our scrolls by with this solution, we simply track the query value as we are used to with the task, and if the query is empty, we return our empty list, and otherwise we return the search result, which is a promise actually. To consume those results resource, we can use the resource component provided by Qwik. It gives us some handlers which we can use to render out various template parts depending on the value, which can change over time. As we can see, this solution also is well suited for good time to interactive, because no JavaScript is loaded initially, and when we enter a value, the dependent JavaScript bundles are fetched. So with useResource, we have a more declarative approach to data fetching. 3 major benefits of this approach are: the first execution happens on the server, and we can provide data during SSR if we like. Furthermore, we don't have to hold the fetching state in a separate signal or store. Instead, we can use the resource component, which takes care of this. Last but not least, rendering out the errors is also trivial. So when it comes to async loading, useResource is your friend. Our last use case is synchronizing component state. This does not relate to performance, but it's more a code quality thing. We can use useTask to synchronize component state. In this double count example, we have 2 signals which should be synchronized with each other. The double count should always be count times 2. With useTask, we can simply track our count signal and then multiply it by 2 and update the double count. To get this running, we simply render a button with an onClick handler, which updates our count value. The current count value is rendered together with the double count value within the button. Let's see this in action. Initially, we have no JavaScript. If we hit the button, it is updated accordingly and the JavaScript gets loaded. What's nice about this solution is that the double count value is calculated in a single place. We don't have to care about the double count when we touch the count value. One alternative would be to simply update the double count value where we update the count value. But this approach is more error prone because we always have to think about updating the double count as well. Of course, this also works and it's a bit less code, but I think it's better to have the update logic in one single place. Finally, we have a useComputed function from Qwik, which we can use to derive state from existing state. And this state that is referenced here in this function will be automatically tracked. So double count will always be in sync with our count. We can also run this in the browser and the result looks pretty the same. The useComputed function is my favorite here. It is already calculated during SSR, it is lazy and it's very concise. Okay, as we saw, there are often better solutions than using tasks. So why are tasks provided by Qwik and when should we use them? There are still some situations where it makes sense to use tasks. For example, we can use the useTask factory together with an isBrowser guard and then lock some information or store data in the local storage. And sometimes the execution of a useVisibleTask is precisely when we need it. Some pages make use of it to animate parts of the page when the user scrolls by. Another important use case of useVisibleTask is synchronous event handling. If we use function properties or useOn to handle events, the events are handled asynchronously. So let's make use of the full potential that Qwik provides us to build high-performance web pages. And if you want to always have a bird's eye view over Qwik, you can download my cheat sheet, link in the description below. In this sense, never stop learning and see you in the next video.